So here with Robert Henson, you spent an awful lot of your career with the National Center for Atmospheric Research. And what would you say were the primary things that you did in your years there?
I did a lot of writing and translating of the science that's carried out at NCAR across the world and in many different realms of atmospheric science, oceans to solar physics and all that. But one of the real standout things was being on board when climate change first really hit the national psyche in early 1990s, when the IPCC was formed, not long after Yellowstone. A big chunk of Yellowstone burned down, and there was a terrible drought in 1988 in the Midwest. And there was just an increasing concern at that time about what climate change could bring to the nation and the world. It was really wonderful to be working with the top-notch scientists at NCAR and learning as much as I could. I was like a sponge, just soaking it all up. And I came to NCAR from childhood of interest in extreme weather and tornadoes. So it's an interesting journey blending those perspectives of all the things that weather can do and all the possibilities in which that might evolve and change as our climate warms.
Okay. Now, we had talked earlier about, we started with this as global warming and then it transformed into being talked more about climate change. Was that a branding issue, if you will, or how did that come about?
Well, the term global warming actually came into use as far back as the 1970s. There was a paper in Science that asked the question, are we on the verge of a pronounced global warming? And the forecast in that paper turned out to be very accurate. That was, I think, in 1972. So global warming slowly gained traction, but most people didn't hear the phrase until the late 80s, early 90s. But by that point, it was becoming clear that some of the bigger problems might not be the actual temperature rise, but the changes in precipitation. The fact that when it's dry, a warming climate will make it even drier, and where it's raining or snowing, the enhanced water vapor with the warmer temperatures can make it rain or snow harder. Mm-hmm. So you've got both ends of the hydrological spectrum intensified. Some call it the wet get wetter and the dry get drier. So because global warming doesn't really capture that piece of the whole puzzle, there was a general practice among scientists to start referring to it more generally as climate change. And in fact, in 1990, the founding of IPCC, it was dubbed the Intergovernmental Panel on Climate Change. So that phrase has been around now for around 25 years.
Right.
But a lot of folks have said, well, it used to be global warming and now it's climate change. Well, it's really always been climate change, but I think climate change is just a more accurate way to talk about not only just what we're seeing now, but the climate changes that have happened in the past because of mainly because of changes in the tilt of the Earth that are very predictable, but over hundreds, thousands, and millions of years.
And the fact that it is not just temperature, but it's precipitation and other things as well.
Yeah.
How does it make you feel as a scientist to have somebody say that this is nothing more than a political agenda, that science is being used for the purpose of furthering certain policies, and that there's no real truth to the science? Someone who has put as much effort into this as you have, and you've been around people that have put a lot of effort into this, just very bluntly, how does that make you feel?
Well, I'll tell you, I know people who have dedicated their lives, 50 years of their lives, for just studying this, that began in the 50s and 60s. Warren Washington, who joined NCAR in 1963 and created one of the very first climate models ever developed in the world. There are people that have been interested and passionately cared about this topic and understanding it better for decades and decades. I know from firsthand experience and from knowing all these people that it's not a politically generated issue. It's a real concern and a real problem and a science problem. Now, there are political aspects to it, obviously, and that's the big problem with climate and climate change is figuring out what to do, right? That's our problem as humans and as societies, is what are we going to do? Those are political and economic decisions and personal decisions in some ways, but they're not science questions.
Right.
The science is the physics and the chemistry. What happens when you put a molecule called carbon dioxide that you can't see, you can't smell, you can't taste? What happens when that goes in the atmosphere? Well, it absorbs heat that's trying to escape from Earth. Mm-hmm. What happens when you put 34 billion tons of this invisible substance in the air? That's what we're doing every year. So that's the science. there's so many ramifications to what will happen as the CO2 burden increases. There's so much to learn still. There's a lot we do know. All those are separate from what are we going to do about it. And that's where the politics and the economics come in, and that's where the politics should come in, because that's why we have political systems and systems of government, and that's why we have activism, that's why we have personal decision making. It all becomes important, but it does frustrate me when people say that this was all spun up as part of a political agenda, because the science transcends any political party, transcends any political movement. It's core science that's going to be around for hundreds of years.
Right. Is there any chance, and of course this gets into the whole realm of uncertainty, is there any chance that there could be a system of feedbacks that would, in the end, nullify the chance of a climatic catastrophe, if you will, that we don't know about or don't fully understand yet?
Well, anything I suppose is possible. We don't know what we don't know. But what we do know is that there's no immediate, meaning in the next, say, 100 years, there's no immediate system that's going to slow things down short of a massive number of volcanoes, right?
Okay.
If we don't have that, we're going to warm up globally, right? Now, there's still a lot of question marks, even over several decades, as to how much will any, for example, city in the United States warm up. There's been some interesting work showing that could vary quite a bit in certain cities. So Seattle is one example. Other cities, like say in the Southwest U.S., there's more confidence they are going to warm substantially. So the local effects, there's quite a bit of uncertainty, but I don't think any scientists that I know see any kind of saving mechanism that can nullify or erase what's happening in terms of the energy. It's just too massive an amount of energy.
And one of the things that I really wasn't aware of until a few years ago is that the effects of this are not all above ground, that the acidification of the ocean is huge. Can you speak to that a little bit?
Sure. This is kind of or the less appreciated side of climate change, I think. There's not a whole lot that's reported on the fact that the oceans are becoming more acidic over time. They're still actually alkaline, but they're moving towards becoming acid.
Okay.
So we call it acidification because it's moving in the direction of becoming acidic. But that's been a very steady increase over the last 100 years. We think over time it's going to affect marine life in a lot of different ways, and there's a lot of good scientists working hard to understand what that's going to be, but there's absolutely no doubt that this is happening. And it does pose a problem when we talk about controlling the problem. There's been a lot of discussion about kind of engineering our way out of climate change. Like and this is certainly something that could be done. You can shoot a bunch of smoke into the stratosphere by flying lots of planes. That smoke could block sunlight, and you could probably lower global temperature, but you'd have to keep doing it. And at the same time, the carbon dioxide would still be building up in the atmosphere. That would still be making the oceans more acidic. So it's a real concern, and I don't think it gets the attention it should get, because it's one of the most absolute markers of what's happening because of greenhouse gases.
I guess this really isn't a science question, but we've talked already about how politics has played a role, and it seems like there's an almost binary-like division, even though the majority of climate scientists agree that man is having an influence. That the public split on this is very, very different. How do we get to a point where we're less binary, and this is probably more human behavior than it is science, but where we can at least discuss this and not have it be riddled with conspiracy theories and political motivations and all of this, where let's just look at the facts, sort of a Jack Webb type approach, and come to some conclusion about how we can do this, how we can deal with it.
I'm optimistic. I've always been an optimist, and I like to think that we will get there, and I think we are getting there. It's not easy because our political climate, our social climate right now encourages polarization. It encourages thinking in terms of you're in one camp or the other, you're with us or you're against us. And a lot of issues are more broad than that, and really I think we had come to terms of agreement on the basics of what's happening. I think about something like smoking, which was considered somewhat controversial, the health effects of smoking maybe 20, 30 years ago. And now there's much less, portrayal of it as being uncertain. We know that smoking harms your health, and we've made public policy along those lines, right? You can still smoke, obviously, but I think in the similar vein, we're going to find areas of agreement on climate change. I think one of them is energy efficiency. I think we all would agree that doing things as efficiently as we can is a good thing, right? Sure. Cars are becoming more efficient. The U.S. is actually producing more per unit energy than we ever have. We're doing a great job at becoming more efficient, and many countries around the world are doing the same. So there's hope there. And I think if we can just think of the science, and I try hard in giving talks, it's like taffy sometimes, to pull out the politics from the science and focus on the science. And certainly it's complex science, and certainly people will disagree on pieces of it, but the foundation, the bedrock, there's a substance that absorbs heat. We're putting more of it in the air. We know that if you put more in, it should warm up globally, and it has been warming up globally.
Right.
Like, all those things are pretty foundational. And all the rest, including the fact that the eastern United States was way cold this past winter while the rest of the world was way warm, to me that's tremendously fascinating. But it doesn't mean climate change is not happening. It's simply one manifestation that we didn't expect.
Right. As much bashing as the climate models, or as some people try to give them, it's interesting to me that all the way back in the 80s, and I'm assuming that the climate models back then were far more primitive perhaps than they are now, indicated that the majority of the warming would occur in the Arctic, in the high latitudes, and that is precisely what has happened.
Yeah. The fundamentals of climate models that have been around since the 80s are simply taking in the heat from the sun and processing what happens to the heat as it works its way through the oceans and sending it back out. And that has painted a pretty clear picture all the way back, as you said, to the 80s. The poles are going to be warming faster than the tropics. We'll be warming more at night than during the daytime, and that's certainly been happening in a lot of places. So yeah, a lot of those things have been pretty solid. Another kind of emerging constant in the models is that it's going to be getting wetter at high latitudes, say in Canada, and generally getting drier in the subtropics, the far south sunbelt of the U.S., especially the southwest U.S. And that seems to be becoming more and more consistent in the models. Most of the U.S. is in this uncertain range in the middle, where we could be on the dry side or the moist side. But one thing we do know is that when it is droughty, when it's not raining, the warmer temperatures are going to pull more water out of the ground. So droughts impacts are going to be worse.
And uncertainty is not to be equated with we don't understand anything. We still understand a lot. Every detail, no, but that's not reason to discredit the entire science.
No, we know enough to know that increasing our emissions adds more uncertainty to the climate system and puts us closer to a point of potential larger ramifications. I think especially sea level. Seas are rising, there's no doubt about that, and we know that seas are going to continue to rise. Will they rise at a more rapid pace or less rapid pace? That depends in large part on what happens with global emissions. So that's a pretty clear-cut decision, and obviously we're not going to stop all our emissions, but can we make legitimate moves toward reducing them? Yeah.
Sure.
And whatever we do helps. We're not going to solve the problem or fix it, but we're not going to wave it away either. We have to find some middle ground where people from all parts of society can agree on pathways that make sense.
Gotcha. So I guess the basic question is, what if you're wrong? What if this conglomeration of scientists, that everything that they've concluded over the past 20 or 30 years turns out to be not right?
Well, I think the chances of every major scientific society on the planet being wrong about an issue of this magnitude are pretty low. But granted, it could happen. So let's say it amazingly did happen. And let's say we had taken reasonable steps, we've become more efficient as a society, we'd reduce the amount of pollution, not only carbon dioxide, but particulates, soot, the things that actually cause several million deaths around the world each year, if those were reduced. if all these things happened and it turned out we were wrong about climate change, well, think of all the benefits we would have had because of the steps we would have taken. Think of all the additional oil, coal, and gas that we would have to use later on instead of having used it all up now.
Okay.
They're miraculous. Fossil fuels are miraculous fuels, and I think I'm actually quite conservative about fossil fuels. I think they're worth conserving because they are so powerful. Really, we're taking energy that's built up over thousands, millions of years, and we're using it just like that.
Gotcha.
That's why they're so tremendously helpful. It's also why we need to be smart about using them. I guess I call myself a worried optimist, because ultimately I'm optimistic about humans, our ingenuity, our ability to adapt, and I'm not worried that the world's going to end. I don't think we have to save the planet. I think the planet will be just fine. I do think if we want to preserve the world as we know it, and preserve coastal cities, and preserve various aspects of the way we know the world, then we do need to think about some actions to take.
Right.
And I'm hopeful that enough of those will make sense and will gain enough popularity and prove themselves to be worthy that we can make it happen. I think it will take the whole world. I don't think the US or China or India can do it on their own. We have to think together and plan together as a global community. And there's many ways that can take place. I think we have to leverage the power of the marketplace. I think, sorry.
What? Oh.
I'll start that one again.
Okay.
I also, I think we need to leverage the power of the marketplace as well. I think there's so much that can be done to help people to have the choices they want to make, to be able to get more efficient cars, to heat and cool their homes more efficiently. We have so much low-hanging fruit simply in the way we use energy to heat and cool houses. You know, there's little things that can be changed for incentivizing actions. For example, many people rent their homes, right? Well, if you rent your house, you're not going to be motivated to put insulation in to reduce the heating or cooling, right? If you own the house and the renter is paying utility bills, then you're not motivated either. So how can you structure it so that those efficiencies get done, and then it's a win-win for everybody?
Gotcha. Now, I just thought of one thing I wanted to ask before, that obviously because of the political nature of this and other issues in this day, that there are advocacy groups on both sides that take certain issues and try to use them to their own advantage for whatever they're advocating. I'm wondering if there have been times when you have been frustrated, at least somewhat, by groups that are technically in agreement with you, that believe that man is having an influence on the climate and that it is a serious issue, but they overplay it, and by doing that damage the credibility of otherwise good science.
It can happen. I think there are groups that will run with the science a little too far. Sometimes the science gets distorted a little bit, even in little ways. I was really frustrated when the movie An Inconvenient Truth came out, and the chimney, the smokestack coming out of a chimney and forming a hurricane was actually rotating the way it would in the southern hemisphere instead of the northern hemisphere. So that was annoying to me, although I thought most of the movie was very solid. But yeah, I think more generally, activist groups will run with whatever facts they have on any side of a question, and I think it's important for citizens to be aware of that and to focus not on what an advocacy group is telling you. If you agree with the actions they're taking, you may want to take those actions, but look for legitimate sources, look for well-vetted sources, look for multiple sources and see if they're confirming what you're seeing. National scientific societies, American Meteorological Society, those are excellent sources. IPCC is a great source. NCAR-UCAR has some excellent public materials. I think
you've written the book yourself?
I wrote this book, the Thinking Person's Guide to Climate Change. So, and I tried real hard in here not to preach to any choirs, because I think the choirs don't need to be preached to. None of us do. I think it's important for people to just be able to find the information, and it's difficult because many of us are not experts on many topics, and so we're relying on people that we trust to tell us what we need to know. On climate change, there are good sources out there. One I really like is called Skeptical Science. It has answers to 100 questions that people commonly ask. And those questions are answered at 3 different levels of depth. so you can find the level you're looking for.
Okay.
But it's real important to especially get the basics down. You know, carbon dioxide is increasing. We know why it's happening because we're putting it in there by burning fuels. We know that the global temperature is warming. It warms sometimes at a greater rate, sometimes at a slower rate, because sometimes the atmosphere is putting more heat into the ocean, sometimes less. We're entering what looks like a period over the next 15 years of a more rapid warming in the atmosphere again. Those things aren't too controversial, especially the basics of what we're doing to the atmosphere.
Gotcha.
There's just no question about it. And if you try to invoke anything else, like the sun, changes in the sun, volcanoes or whatever, well, first you have to show that those are happening, and there's not much evidence that those are large enough to do what we've seen. You also have to explain away carbon dioxide.
Right.
And we know from Venus what carbon dioxide does, among many other reasons, among laboratory experiments that have been done for 150 years.